This is a high school geometry lesson on the law of sines and the law of cosines. First off, let's remind ourselves about right triangles. Remember that trigonometry has all to do with right triangles. If you've got two sides of a triangle, the easiest way is probably going to, of a right triangle, the easiest way is probably going to just be to use the Pythagorean theorem. And remember the special cases of the Pythagorean theorems of special right triangles. So that would be an isosceles, which is the leg times the square root of 2 is the hypotenuse, and then a 30, 60, 90 is the short leg. The hypotenuse is twice the short leg, and the medium-sized leg is the square root of 3 times it. These are really handy shortcuts, and you should remember them. Now, for trigonometry, what you need is an angle and a side. Of course, it's right triangles. All of this is right triangles. However, we're going to venture out of the world of right triangles into the law of sines and cosines, where technically you've got a right triangle, but it doesn't look like it. You don't have anything that looks like a right triangle. But the trigonometric functions still apply because of how we deal with our non-right triangle. So here, we'll start with the law of sines. So the law of sines, we've got a triangle that's not right. Oh, look, you can take any one of those and make it into two right triangles by dropping a hypotenuse from one of, by dropping an altitude from one of the vertices. And now I've got not one but two right triangles. How would I deal with those? I would look at them here separately. Okay, first off here, I look at my left side triangle. I don't want to use this blue portion because I don't know the length of that. I don't know where my altitude hit the side. So I want to use a side that I know, which is B, and I'm going to need to use the height or altitude in some fashion because it's a right triangle. What will that be? Oh, let's see. That will be the opposite relative to A. The height is opposite, and B is the hypotenuse. Okay, so that's the sine. I can write that the sine of angle A is H over B. I can do it for the right side triangle the same way. The sine of angle B is H over A. Oh, look, opposite over hypotenuse. If you do a little bit of algebraic manipulation, I can isolate the H's in both of them, and I notice, oh my goodness, two things that are equal to the same thing are equal to each other. The transitive property, so I set them equal. B sine A is equal to A sine B. This is the law of sines, but it's more convenient in this fashion. It's shaped like a proportion. So I divide both sides by B times A, cancel the B's, cancel the A's, so that I have very simply and easy to remember the sine of A is to A as the sine of B is to B. Now for each one of these, I can do it 3 times with this acute triangle. For example, right here, I could drop an altitude from B, and then I'd have two triangles that are right triangles. I could do exactly the same thing. I could drop an altitude from A. I'd have two right triangles, and I could do exactly the same thing. Since I can do it all this way, you can say for each one of the angles and opposite sides that the same principle holds. So what we have there then is the law of sines in its 3 iterations, or incarnations, one or the other. So the sine of A is to A as the sine of B is to B, as the sine of C is to C. Very easy to remember. Now remember, this is for any triangle. It'll work for any triangle, not simply for right triangles. So even though it utilizes trigonometry, we've done that little pass-through of the altitude and canceled it out, got rid of it, transitive property of that, so that we don't have to deal with it, so that we can find the parts of the triangle without having a right triangle. Okay. Now, something about this, let's remember that the triangle is labeled in the traditional fashion, and that is that angle B is opposite side B, big B, little b. Angle A is opposite to side A. Angle C is opposite to side C. So each one of these represents an angle and its opposite side. Okay, it's going to be a proportion. For the proportion, you need just two of them, so you can pick any two. You can say the first two, and you solve that as the proportion. The last two, solve that as proportion, or the first one and the last one. Any of those will work. Notice what you have when you do that. Proportion, you're going to have 3 out of the 4 to be able to solve it. So in either event, you're going to have an angle and its opposite side. Then something else. Doesn't matter what else, but you're going to have an angle and its opposite side to be able to apply the law of sines. Let's look how that works. Okay. Oops. Here's an example worked out of the law of sines. Okay? So we have a triangle that's not a right triangle. We need to solve the triangle. To solve the triangle means find every side length and every angle measure. Okay, well, angle C is easy. Triangle sum says they all add to 180, so you just subtract them out and find out that angle C is 66 degrees. Okay, now recall, you've got to have an angle and its opposite side to use the law of sines. So you look around here, and you notice that the only place that happens is with angle B and side CA, or side little c. So you have the angle and its opposite side. So we'll use the B couple there. The sine of 85 is to 9 as and we'll start with A, doesn't matter, and do the A pair, the A coupling, whatever. The sine of 29 is to our variable A. So this will find for us what the side length A is. We work through it, put it in the calculator or work it out, and find out that A is approximately 4.4. We do an analogous thing for the other one, for side C. Notice that I've used the one that I know. Sometimes, this one's just as good. I know that one's 66. Okay, but I'm not going to use the A grouping, angle A and side A, because this is an approximated amount. It was irrational. It got approximated. And if I use it again in here, I may compound my error. So that's not good. It's kind of like intermediate rounding. If you can get around it, don't do it. So I'm going back to B, angle B and side B, rather than using the A that I found. If this had come out to be a whole number, then it would be fine. But otherwise, use the best A that you have to do things. Okay. Now the law of cosines isn't quite as easy to explain. I'm not going to take the time to do that at this level. Mainly we need the tool in our toolbox of formulas and how to use them. So make note of these. This is the law of cosines. It's one law. It's just 3 iterations of it based on angle A, angle B, or angle C. As you look at it, notice that it looks a whole lot like the Pythagorean theorem. Okay? So there's the Pythagorean theorem, and then there's a corrective. Okay? And the corrective has to do, at least in part, now this is just in general gut terms, this is not technical proof. It has to do with the ratio, at the cosine ratio. So what that means is, as we vary from it being a right angle, like for example with angle B, if I drop an altitude here and I'm using angle B, if this were a right triangle, then the cosine would be this portion over the hypotenuse. As I move out and make it not right and change the length of my adjacent side, the change is in the relationship of the ratios. That's why the ratio is there. It's not exactly that, and that is not a proof, but that kind of helps me remember what I need to do. I think of it as basically the Pythagorean theorem with a corrective. You need yourself a way to remember it because you need to memorize it. And that is the way I do it. If you come up with a better way, tell me. Is I have the angle and the side that match up. They're opposite each other. So here's the C's, the B's, the A's. And the in-between, say for C, there's side C and angle C. And everything in between is an A and a B. There are no C's. For angle B, there's side B, and everything in between is not B. It's either A or C. Same deal here. Angle A, side A, everything in between, there is no A. It's only B and C. That helps me memorize it. If you come up with a way to do it, let me know. Okay, an example of how to work it out. It's tedious. Tedious, tedious, tedious. But it works. It's a good tool to have in your toolbox. Good area to have in your math quiver there. Here's an example of working out the law of cosines on this problem. Okay, we have a triangle that is not a right triangle. You've got to look and see what you have. The best case, the easiest case for the law of cosines is when you have an angle that's included between the two sides that you know. That's where it works the simplest. And that's what we have here is 45. And so the angle I have is B. So I've chosen the form of the law of cosines that has angle B in it. So I'm solving for side B, which conveniently is the one I want. I plug it all in, and then I plug it all in, and then I get down that the answer is approximately 61.1. Okay, that's just tedious work. You can get it. You can get it. Here's another example. Now notice on this one we don't have any angles. It'll still work out. It'll work as long as you have all of the variables except one. Here we have that, and we just plug it in. This one is even more tedious. We come down and we have to do the inverse function, arc cosine, and we'll get it. So plug in all the data, go through, and find out in here that we have angle A is approximately the measure of 41.4 degrees. Okay, one more thing about the laws of sines and cosines, and that is that it can be used, this type of argument, this is not actually the law of sines and cosines, but you can use it to find out the area of any triangle. So I have here a triangle that's not right. I don't know if that makes it wrong, but it's not right anyway. What's the area of a triangle? Well, it's half a base times height. Here you need to know the base and you need to know the height. Well, the height we don't know, that's the problem. You know, there's a lot of these problems that you just can't work because you don't know the actual perpendicular height. Now, when you've been doing tests up to this point, they've given you ones you could work, but most triangles, that's not always the case. So half a base times height is just the generic area of a triangle. So we need to be able to find the height in some other version so that we don't have to know exactly how big it is. Well, sine comes to the rescue. This take the right angle here, which is the angle on the right, B. Relative to B, we can write the sine as h over a, the adjacent, opposite over adjacent. Okay. Then solve for h, because h is what we want to substitute out. Once we've done that, we have that a sine b is the height. So you can put it in as the height. And then the base is still c of the whole triangle. Now we're doing the whole triangle. So half a base times height. Now it's written here AC instead of CA just because it's good algebraic grammar to put the letters in alphabetical order. So here we can solve any triangle for their area if we know an angle and a side. Okay. Here it's written out in its three versions of what you need. And again, make sure that you're careful to keep the angle B across from angle side B, angle A across from side A. This is the way that it'll work, and it's pretty much easy to do. Once you learn it, it'll make your life a lot easier. Okay, well, here endeth the lesson.